Welcome, TC Anatomy Physiology. This is the second video lecture of the first section. A little insulin and glucagon today as we focus on a specific type of homeostatic imbalance. And our guest right now, musical guest, is Maroon 5 with Sugar. Insulin and glucagon has to go with sugar, right? So we're going to talk about that here for a little bit. So you may have talked about insulin and glucagon in health class, but we're going to kind of go into a little more detail on how insulin and glucagon actually leads to a homeostatic imbalance. So let's just try to get to the line here. There it is. All right, enough of that. We'll come back to that. So insulin and glucagon, these are two hormones, endocrine system. So let me move my face. So this is kind of, I'm not expecting you to write all this down. We'll get into more detail when we get into urinary system. But we got homeostasis. There's your normal blood glucose level. There's an imbalance. In this case, that imbalance is going down. And so what happens is with that stimulus, you decline in blood glucose level. Maybe you haven't eaten in a few hours. That's going to stimulate the pancreas. So this is afferent. These alpha cells in the pancreas are going to release glucagon. So glucagon, you might want to jot that term down. But glucagon is the hormone that is responsible for activating the conversion of glycogen into glucose, because glucose is that sugars end in ose, that your body uses. Glycogen is stored, glucose is what can be burned in the mitochondria during cell respiration. So what happens is that glucagon causes glycogen to go through hydrolysis to release glucose, and that glucose then will enter into the bloodstream. It's released from the liver. So the glucose released from the liver into the bloodstream. It'll circulate, and then that imbalance, it'll come back to that normal. So your body is constantly doing this. So it's either constantly releasing glucose or storing glucose. So here, this is an example of a negative feedback mechanism because you're trying to return to that set point. So this is an example. So glucagon is released when blood sugar is too low. The one you're probably more familiar with, and again, let me get my face out of the screen, is if blood sugar is too high. So you have a rising glucose level. So here's our homeostatic. Here we are in homeostasis, set point. Too much sugar, right? I ate a bowl of Fruity Pebbles or Frosted Mini Wheat with like 64 grams of sugar. I don't know if it's 64, maybe it's 46. There's beta cells in the pancreas are now going to secrete a hormone called insulin. Insulin will go to the blood, into the liver, into the muscles. And what insulin does, it causes glycogen to form. So think of glucose as like a single Lego. It's a monomer. A bunch of glucose together will form glycogen, which is a polymer. And so what will happen is that insulin causes glucose to be stored as glycogen. And so what will happen is your body is going to take up all this excess glucose, stored as glycogen. That binding of insulin in the liver, hepatocytes, and muscle, it triggers a secondary messenger, which we'll get into a little bit later. But ultimately, you're storing glycogen. The glucose is removed from the blood, and then it's going to keep returning. We're going this way. This is my imbalance. We're too high. It's going to keep releasing that glucose to get to that set point. So how insulin works, it's a protein hormone. It arises at the liver. It binds to a receptor in the cell membrane. These right here, here's your receptor. There's your glucose. And what it does, when glucose binds that receptor, it stimulates this pathway, right? There's a secondary messenger system, and it activates this insulin receptor to accept insulin. And then that insulin activates that insulin receptor, and then that causes the storage of glucose into glycogen. And so it's a little more complicated. Take AP Bio, we go into more of this, but this is like glucose, then insulin. The glucose activates the insulin. Let's talk about diabetes a little bit. So the top picture, healthy, right? There's a healthy pancreas. It's releasing insulin. Insulin receptor is able to do its job, takes in glucose through GLUT4. Type 1 diabetes, which is about 5-10% of people who have diabetes. And type 1, the body's immune system actually destroys, I'm going to have to put my face up here, actually destroys the beta cells that release the insulin. So eventually your body does not produce the insulin. Without insulin, cells can absorb glucose, right, which they need to produce energy. So if it can't absorb glucose, you may oftentimes hear about people losing weight. So in type 1, it's almost like an autoimmune disorder where the body's immune system is attacking those beta cells. Type 2, let me read this first and then I'll move my face. This is about majority of people who have diabetes, it's type 2. And what happens is your body can't properly use insulin that's released. And it's often called insulin insensitivity. Or it doesn't make enough. As a result, the sugar builds up. So type 1, autoimmune, right? Type 2, this is where you can't properly use the insulin. And so in type 2, you're producing insulin, for whatever reason, can't activate that receptor. So, all right. So type 1, no insulin, cells do not absorb glucose. Type 2, cells do not absorb glucose. Ultimately, 1, insulin's not being produced. 2, cells do not respond to it regardless of what happens. Cells do not absorb glucose. If you do not absorb glucose, you can't essentially perform cellular respiration. Just trying to see what page this is, 36. All right. So how does diabetes lead to glucose in urine? So sometimes you hear about people with diabetes, and they'll talk about having to go to the bathroom a lot. So type 1, insulin's not produced. Liver does not take up that glucose from the blood. Type 2, liver does not take up glucose from the blood. You see a theme. Result, your body's going to get rid of it. So to get rid of that excess sugar, since it's high, it's going to go out through your urine. So what happens is in the kidney, all glucose is passed through renal filtrate through ultrafiltration. What happens is, since there's too much glucose to be processed by active transport, it's just released through the urine. So essentially what happens is there's too much glucose in the blood, and your kidneys filter the blood, and that's how it gets rid of that excess excess glucose is through the urine. And you can pause this, and I'll put some links for you guys to get a little more information. So again, quick review. Treatment for type 1, test it regularly, your blood glucose, inject it when it's too high. Maybe one day we might be able to replace those beta cells with stem cells. We're not sure. I'm not sure enough about that research. Type 2, you can often just adjust the diet. You're trying to avoid the sugary foods. Exercise and weight loss will often improve insulin action. So there are treatments available. Here's the prevalence. You can look at the map. We may talk about this a bit later, but there are definitely parts of the country where type 2 is more relevant. And again, with type 2, if you can control your sugar intake, right? So, and again, that little spot down there is Puerto Rico. We have, let me move my face, and then if you're looking at Alaska and Hawaii. So, type 2 diabetes, right? So, risk factors, if you eat a diet high in fat and low in fiber, is not good, right? Often obesity is a major issue, and that's due to overeating and lack of exercise. So my father is type 2 diabetic. He eats like crap. I tell him, he doesn't listen. So genetic factors can also influence fat metabolism. So here's some things, though. Factors that you cannot fix if you're old, right? You have relatives that are diabetic. You have medical conditions. You have high-risk ethnic background. Gestational diabetes, right? During when a woman's pregnant, sometimes she'll develop it. Factors you can improve: high weight loss, exercise, right? If you're not doing enough activity, you need to get out and do some activity. High blood pressure can be regulated, and cholesterol numbers. So these are all ways that you can actually, there are some factors you can't control, but there are factors that you can improve. So again, this was just a quick overview of diabetes, and let me just kind of wrap this up here. So if type 2, we're going to focus on this one because 95%. Some of the symptoms: you have elevated blood glucose, you're going to have glucose in the urine, and often dehydration and thirst are some of the factors. So feeling unwell, feeling tired, going to the bathroom a lot, excessive thirst, right? So, but these could also be some other factors from other disorders, or maybe you've just not eaten enough or drank enough water that day. So again, this is my wrap-up of type 1 and type 2 diabetes. So what you need to know from this slide is, what is diabetes, type 1 versus type 2, and some of the treatments. So again, we're going to pick back up with Maroon 5, a little bit of sugar. That's going to play. Maybe not. I'm getting a little wheel of death here. All right. So anyways, hopefully this helped, and I will catch you in a later presentation. This is me signing off from 102 on Tiffin's beautiful South Side, room 102 in the heart of Columbian High School. Gotta jam out a little bit.